Hello and welcome to another lesson on GCSE physics. Today's learning intention is to know how we get electricity to our homes. And the first task that I would like you to do for me today, please, is have a think about what you already know about how electricity that's generated in power stations gets to our homes. Write down your ideas, and then as we go through the lesson, we will see if any of those ideas were in fact part of the system that currently exists. So today's success criteria for today is to know what the national grid is, to know what step up and step down transformers do, and to be able to explain why transformers help to improve the efficiency of the national grid. So what I would like you to do before we continue with the rest of the lesson is to click on the link to this YouTube video and have a watch of it. It's a very good animation that explains how electricity gets from the power stations where it's generated into our homes. So as that video has just explained to us, the national grid is actually a system of cables and transformers that connects power stations to the consumers. One of the biggest misconceptions that comes up when we're in class is that people often think that the pylons that hold up the transmission cables are a part of the national grid, and that does get penalised by the examiners. All that we would say the national grid actually is the cables and the transformers, and that is what connects power stations to our consumers. Now obviously the video went into what step up transformers and step down transformers do. The point of a step up transformer is to increase the voltage or the potential difference, and it lowers the current as well, and we do that so that less energy gets wasted along the wires. Then obviously at the end of the system as well, you've got the step down transformers. They do the reverse. They decrease the voltage, which is also called potential difference, and they increase the current. And that's so that it's safe to use in our homes, and when it gets into our homes, it's normally about 230 volts and 50 hertz. Okay folks, what I would like you to do now please is have a go at the questions that are on this worksheet, and then we'll go through the answers together. So if you want to pause the video and have a go at them on some paper, that would be fantastic. So the first question said that the national grid uses transformers to transfer energy efficiently, and it says which two of the following quantities are changed by a transformer. Now the correct answers to those is the potential difference and the current. That might have confused you slightly because obviously we used the word voltage before, but changing the voltage basically means changing the potential difference. Potential difference being the scientific word for voltage. The next question says, describe the difference in the function of a step-up and a step-down transformer. Well, a step-up transformer is one that increases the voltage or the potential difference, and the step-down transformer is one that decreases the voltage or the potential difference. Question 2 says, figure 1 shows the diagram of part of the national grid which transfers energy from a power station to a home, and as you can see there it shows you that in a little diagram starting with the power station, and it says which types of transformers are A and B. Well, if you've got this correct, you'll have said that A is a step up transformer and B is a step down transformer. Okay, question 2.2 is the first extended question that we've got to deal with really. It's 4 marks, and it says explain how transformer A helps to improve the efficiency of the national grid. So to answer that question, we get 1 mark for saying that because it's a step up transformer, it increases the potential difference. The second mark will be for saying that that causes the current to decrease. Then we can say because the current has decreased, that means that the wires don't get as hot, and so less energy is wasted to the thermal store of the surroundings. That's the third mark. And then the final mark is saying that that means that less energy is wasted. And then finally, to finish off this set of questions, it says explain the purpose of transformer B, which is of course a step down transformer. So the purpose of that is to reduce the potential difference down to a safe level, which will be about 230 volts in the UK, so that it is safe for use in people's homes. Right then, the next thing that I would like to have a do for me, please, folks, is to have a go at one or both of these sets of questions. There's a set of questions at grade 4, which are basically recall questions, and then grade 5 is more to do with some calculations from a previous lesson. Pause the video, have a go at them now for me, please, and then we'll go over the answers. Right then, let's have a go at the answers for the grade 4 questions. So the first one was, what is the colour of the live wire inside a plug? That is, of course, brown. Then the second question was, what is the colour of the neutral wire inside a plug? That is the blue one. Question number 3 was, what is the colour of the earth wire inside a plug? That is green and yellow stripes. Question number 4, you were asked what is power. There's two definitions you can give for that one. You can either say, as it says on screen, the rate of transfer of energy, or you can say it is the rate at which work is done. It doesn't matter which one of those that you give. Question number 5, what is the frequency of the UK mains electricity supply? That is 50 Hertz, and we write Hertz HZ. And then question number 6, basically summarising today's lesson really, what is the national grid? It is, of course, a system of cables and transformers that connects power stations to consumers. So now we move on to the grade 5 question. The first one was, why does the national grid contain transformers? Well, there's lots of things you could say for that. Probably the most obvious answer is that the reason we have transformers is that it makes the transfer of electricity much more efficient. You could then go into how it does that, and it does that by increasing the potential difference and lowering the current, which means that less energy will be wasted because less energy will be transferred to the thermal store of the surroundings. Question 2 is a quick recap to do with some of the calculations we've done in the previous lesson. It wanted us to write down the equation that links potential difference, power and current, and that correct equation is power equals potential difference times current, which you could have written down in symbols as well as being P for power, V for potential difference, V of course voltage, and I being current. Question 3 wants us to do something with that equation. It wants us to work out the current flowing through a bulb when the potential difference is 30 volts and the power is 30 watts. So the way I would get you to do that is to write down the equation that you use, and of course you should always do that. Now, because we want to work out the current, we need to rearrange that equation. The easiest way of rearranging an equation, you all know of course by now, is to use a triangle, and it's going to have power at the top because potential difference and current are being multiplied together. We then use that triangle and we find that current is power divided by potential difference. So we do 30 is the power, 30 is the potential difference, and 30 divided by 30 gives us an answer of 1. Don't forget to put the unit on the end, which is amps. Now we begin the final task of today's lesson, which is really a comparative task. I want you to consider, would it be better to lay the cables that are part of the national grid overhead using pylons like you can see in the picture on the left, or would it be better to have them buried deep underground? Now obviously there's pros and cons to both of these. I want you to try and come up with 6 points as to which ones are better and why. Of course both of them have got their advantages and disadvantages. See how many you can get, please. Now, of course, there's lots of answers that you can give to this question, but I'm just going to suggest 6 points that you could have included. Obviously, if you have put the cables overhead, then that means that they are much easier to repair because they're a lot easier to get to. Overhead cables, however, are a risk to low-flying objects like drones. It would be very easy for a drone to fly into the cables, obviously damage the cables and get damaged itself. The overhead cables can also be damaged by severe weather, whether it be thunder and lightning, extreme rain, or extreme winds. And obviously that means they're quite likely to get damaged, whereas if they're buried underground, obviously they're not going to be a danger to drones and they're not going to get damaged by severe weather. However, if we put them overhead, we don't actually need to put any insulation around them because there's no danger of the electricity jumping from those cables down to a person on the ground. whereas if we do put the cables underground, then we do need to insulate them just in case any electricity flows out of them into the ground and electrocutes people. Good things about having them underground are that they cannot be seen, so they don't spoil the view, they don't cause any visual pollution, and also they're much harder to repair though because they're harder to access. So see how many of those you got when you had to go at that question. Any that you've missed, obviously take note of, because you might need to answer a question like this when it comes to the exam. Now that's it for today's lesson. I hope you found that useful, and I will see you next time.